Hi everyone, welcome back. In this session, we are going to learn how to interpret the Black-Scholes model as per the replicating portfolio method. The other two methods, which is interpreting Black-Scholes as per the risk-neutral method and interpreting Black-Scholes as per the delta hedging approach, involve a little bit of mathematics, whereas this, which is interpreting Black-Scholes as per replicating portfolio, almost has negligible math and everybody will understand it. Okay, and let me tell you from an examination viewpoint, I really don't think that interpretation of Black-Scholes model is going to be much relevant, okay, especially for FRM and for CA final. In CFA level 2, interpreting Black-Scholes as per replicating portfolio is partially relevant, okay, because the author for CFA level 2 as of now has actually written in that tone, okay. But interpretation is actually not relevant from an examination viewpoint. It's more for you to understand it, okay. So first, before interpreting Black-Scholes as per replicating portfolio, let us see how we actually applied replicating portfolio method for a single period binomial call option and put option. Okay. First, let's start with call option. If we quickly recollect the facts that we had taken, we had a strike price of 160, a spot price of 170, which means today's spot price is 170. We took the risk-free rate as 7% per annum, the standard deviation of 18% per annum, both of them compounded continuously, and the time to maturity was 6 months. And since we took a single period binomial model, we only have one time step where each time step is for 6 months. Okay. And then we calculated U and D. We calculated U as e power sigma root T, okay, which is exponential. Sigma is the standard deviation of 18% per annum multiplied by square root of time, okay, which is nothing but square root of 0.5. Okay, so exponential of standard deviation into square root of 0.5 is nothing but 1.136, and D is nothing but 1 divided by U. Okay, so we got D as 0.88. Okay, and then the answer over here is basically as per risk neutral method, but I'm going to do the same question as per portfolio replication approach. Okay, and then the upside share price is nothing but S into U, which is 170 into 1.136, and the downside share price is S into D, which is 170 into 0.88, which is nothing but 149.68. Okay, so these are the facts of the question. I'm going to solve this question as per replicating portfolio under a single period binomial. Okay, so let me just quickly come to the notepad. Let me just jot the facts here as well. So we have current share price of 170. The share price could go either up to 193.07 or it could fall down to 149.68. Okay. Remember, the answer that we get under the portfolio replication should obviously be equal to the answer that we got under the risk neutral approach also of 19.41. Okay, so we already know what the value of a call option should be. Okay, it should be 19.41. All right. Okay, now let's think of how a call option can actually be replicated. Okay, a call option, if you think intuitively, it is similar. Buying a call option is similar to buying shares. Okay, because buying a call option and buying a share give you a bullish position, which means you stand to gain when the share price increases and you stand to lose when the share price decreases. Okay, so intuitively, when you think, buying a call is equivalent to buying shares. Okay, but the big difference is when you buy a call option, the premium that you pay in a call option is very, very less, whereas the cash outflow when you actually buy a share is the whole share price, right? The key difference between buying a call and buying a share is that your cash outflow in buying a call option as a holder is going to be just the premium amount, which you know that is just a percentage of the share price, right? It is not, it's just about 10% or something of that sort. Whereas when you buy a share, you're literally paying the whole share price itself. Okay, so this is the main difference. Okay, so that is the reason we look at call option as not buying shares, but we look at call option as leveraged stock buying. Okay, the word leveraged stock buying means you're borrowing money from somebody and then you're buying shares. Okay, what happens is when you borrow money and then buy shares, your own money, which is going into buying shares, is not going to be the full share price, because a portion of that you have actually taken that money from somewhere. Okay, so if you look at t equal to 0, which is today, Okay, your cash outflow is going to be the share price, agreed. Okay, but you also have a cash inflow, which is nothing but the borrowings that you have made. Okay, of course, the borrowing is going to be less than the share price. Only then you will have a net cash outflow today, right? Okay, so call option can be looked at as leveraged stock buying, which means you're borrowing a certain sum of money, you're adding some own money of yours, and with that you're buying shares. Okay, so now when you borrow and buy shares, your own money which is going out of your pocket today is actually less, and it is similar to that of a call option, because even in a call option the cash outflow today is less, right? So call option is not equivalent to buying shares, it is equivalent to leveraged share buying or leveraged stock buying, which means you borrow and buy. Okay, and that is the reason they say derivatives have a lot of leverage, right? This is leverage that we are always talking about. Anyways, so call option is equal to leverage stock buying, but one call option is not equal to one share. Okay, so the way we look at it is one call option is equivalent to, let's say, h number of shares. Okay, so we basically have two unknown variables. One is how much to borrow, and the second is how many shares to buy. Okay, we have two unknown variables, how much to borrow and how many shares to buy. Okay, for those of you who have already watched the previous lecture, this must be only a revision. Okay, so I hope you're able to recollect stuff. All right, so we have two unknown variables. Okay, just give me a second. Yeah. So now what we actually essentially want to do is we are trying to replicate a call option, okay, using borrowing and buying shares in such a way that the payoff of a call option is equal to the payoff of this replicating portfolio. I'll just repeat. What we are trying to do is we are creating another portfolio using borrowing and buying shares in such a way that the payoff of the call option, payoff meaning the cash inflow that you receive from a call option at t equal to 6 on maturity. The payoff that you receive from a call option at t equal to 6 should be equal to the payoff that you will receive from this replicating portfolio, which consists of few shares and which consists of some amount of borrowing. Okay, and when two portfolios have the same payoff in future, they're supposed to have the same price today, which means if call option and this replicating portfolio have the same payoff in future, the call option and the replicating portfolio must have the same price today. Okay, so what we will then do is we will calculate the price of this replicating portfolio, and we will say that the call option price should be equal to the replicating portfolio's cost. Okay, because we do not know the value of the call option. That is what we're trying to calculate, right? So the value of a call option should be equal to the price of this replicating portfolio. Okay, so this is what we're going to do. We're first going to ensure that the payoff of this call option will be equal to the payoff of the replicating portfolio in future. Okay, and then we will calculate the price of the replicating portfolio or the cost of the replicating portfolio, and we will say that the call option should have the same price, because if two securities have the same payoff in future, then they must have the same price today, else there will be an arbitrage opportunity. Okay, in case you have any further doubts, I would recommend you to go back and watch the replicating portfolio lecture. Okay, I can elaborate it only to this extent. Okay, so the strike price that we have is 160. So if we calculate the payoff of the call option, what I denote as VC, the payoff of the call option at t equal to 6 is 193.07 minus 160, which is 33.07. Okay, and the payoff of the call option on the downside will be 0. So the payoff of the call option at t equal to 6 can be either 33.07 or it can be 0. Okay, now we have to try and create a portfolio using borrowing and shares in such a way that they have the same payoff, meaning if the share price is 193, that portfolio should have a payoff of 33. If the price is 149.68, if the price of one share is 149.68 on maturity, that portfolio must have a payoff of 0. Okay, so we are going to try and build a portfolio such that it has the same payoff as that of a call option. Okay, now what I'm doing is I will say let us borrow Y, and buy H shares. Okay, So there are two variables that I do not know. We are borrowing and we are buying H shares. Okay. Now this is an action that is going to be done at t equal to 0. That is today. Okay. When we borrow Y and buy H shares, what is going to happen at t equal to 6? One, we will sell H shares, okay, because we are buying at t equal to 0, meaning we are going to sell at t equal to 6. We will be selling H shares at t equal to 6, and we will have to repay the borrowings. We will have to repay the amount of borrowings that we had actually taken, okay. So at t equal to 6, the first possibility is the share price is 193.07. 193.07, right? When I sell H shares, my cash inflow is going to be 193.07 into H, because one share is worth 193.07, but I am having H shares. So my cash inflow, which I'm denoting as positive, is 193.07 into H. Okay, but I will have to repay these borrowings. I will have to repay not just the principal amount, I will also have to repay principal plus interest. Therefore, I'm now having a cash outflow, which I'm denoting as minus y into, I'm doing continuous compounding. Therefore, I have y into e power rt, where r is nothing but 0.07 and t is 6 months, 6 by 12. Okay, this is going to be my payoff at maturity from this replicating portfolio. Okay, let me define this as replicating portfolio. This is the replicating portfolio, and this is going to be my payoff in future at t equal to 6. And what I said was, I want this payoff of the replicating portfolio to be equal to the payoff from a call option. And the payoff from a call option when the share price is 193.07 is actually 33.07. Okay, so I will be equating this to 33.07. Okay, this is the payoff from the replicating portfolio. And note the situation that I've first taken is where the share price is 193.07. When the share price is 193.07, what I receive from selling H shares is 193.07 into H, and I have to repay borrowings where I'm taking the interest rate as risk-free interest rate, and I'm using continuous compounding, which gives me e power 0.07 into 6 divided by 12. Okay, which means I have 193.07H minus e power 0.07 into 6 by 12 is 1.03562, 1.0356y. Okay, 1.0356y is nothing but maturity value of the borrowings, which includes interest, where the interest is almost 3.56% for 6 months. Okay, 7% for 1 year compounded continuously is 3.56% for 6 months. Okay, this payoff should be equal to 33.07. Now I have second situation where the share price could also be 149.68. I'm not certain that the share price is always going to be 193. There is a second possibility that the share price can be 149.68. Okay, share price is 149.68. What will then happen is when I sell H shares, I will receive a cash inflow of 149.68 into, apologies, I will receive 149.68 into H. Okay, and then I will have to repay the same borrowings, and my maturity value of the borrowings is going to be the same as above, which is y into e power 0.07 into 6 by 12. Okay, because what I have to repay as borrowings is not dependent on the share price, right? Only my sale proceeds from H shares is going to change according to the change in share price, whereas what I have to repay as borrowings will be the same whether the share price is 193.07 or whether the share price is 149.68. Okay, so my repayment of borrowings is going to be 1.0356y. Okay, and this is the payoff of the replicating portfolio at t equal to 6 if the share price is 149.68, and I want the replicating portfolio's payoff to be equal to payoff of a call option, which is equal to 0 at the bottom. Okay, if the payoff of a call option is 0 when the share price is 149.68, Okay, the payoff of the replicating portfolio, I want it to be equal to the payoff of the call option. Okay, only if the payoff of both the call option and the portfolio are equal, this portfolio will only then be called as replicating portfolio, right? I mean, I'm calling it the word replicating basically means duplicating, right? I'm duplicating a call option using a combination of shares and risk-free borrowing. Okay, so basically I want the payoff of the replicating portfolio and the payoff of the call option to be the same. Okay, so that is, so one case is where the share price is on the upper end, the other case is where the share price is on the bottom side. Okay, so this is the payoff of the replicating portfolio. I have equated that with the payoff of the call option, and on the bottom side also I've done the same. If you see, I have now two equations and I have two unknowns, h and y. Two equations and two unknowns, you solve for them as typical linear equations and you will get the answer for h and y. Okay, if I subtract 1 from 2, what will happen is, let me subtract 2 from 1. Okay, so what will happen is 193.07 minus 149.68h. Okay, 193.07 minus 149.68h is equal to 43.39h. Okay, I did basically 1 minus 2. I'm subtracting 2 from 1. Okay, I got 43.39h. This is going to cancel each other out. So I will be having minus 0 is equal to 33.07 minus 0, which is 33.07. So I have 43.39h is equal to 33.07, where h is equal to 33.07 divided by 43.39. H is equal to 0.7622. Okay, h. So basically, I should be buying, because h over here referred to the number of shares, right? I am buying 0.7622 shares. Okay, I am buying 0.7622 shares, which is less than 1. Okay, and then I can substitute 0.7622 in equation 2 to arrive at the value of y. Okay, which I'm doing. So it is 149.68 into 0.7622 minus, or when we take this part onto the right side, it will basically become plus 1.0356 y. Okay, because the RHS is 0. So if I take this latter term to the right side, it will become 1.0356 y. Okay, so 149.68 into 0.7622 is 114.09 is equal to 1.0356 y. Y is therefore equal to 110.16. Okay, so h is equal to 0.07622 and y is equal to 110.16. Okay, so what we are essentially trying to say is one call option can be replicated by borrowing 110 rupees or borrowing $110 and buying 0.76 shares. One call option can be replicated by borrowing $110 and buying 0.76 shares. Okay, and the reason why I'm saying that call option can be replicated is because when you borrow 110 and buy 0.76 shares, the payoff at future at t equal to 6 will be 33.07 or 0 depending on the share price. Okay, and 33.07 and 0 is nothing but the payoff from a call option. Okay, the payoff of this portfolio of borrowing 110 and buying 0.76 shares is going to have the same payoff as that of a call option at t equal to 6, and that is the reason we're calling it a replicating portfolio. How are you so sure that it will have the same payoff? Because I actually calculated y and h by equating them to these numbers, right? Okay, so obviously borrowing y and buying h shares will give me this payoff at t equal to 6 because y and h were calculated from those numbers. Okay, and if you remember, we saw that this h is nothing but delta. H is actually equal to delta, where delta is the change in value of a call option by change in share price, which is y2 minus y1 divided by x2 minus x1. Okay, where y2 y1 is the call option value and x2 x1 is the share price value. Okay, x is the independent variable, which is share price. Y is the dependent variable, which is the call option value. Okay, y2 minus y1 is actually nothing but 33.07 minus 0, which is 33.07. okay, divided by x2 minus x1 is 193.07 minus 149.68. You have 43.39 divided by 43.39. And if you see, actually 33.07 divided by 43.39 is what we actually got over here when we were calculating h. Okay, so this is equal to again 0.7622. So we then said that a call option can be replicated by borrowing y and buying delta shares. Okay, you don't have to actually calculate h using the linear equations. You can actually calculate delta, and you can straight away say that you need to buy delta shares. Okay, so call option can be replicated by borrowing a sum of money and buying delta shares. Okay, now let us calculate this cost of this replicating portfolio. Okay, because we have not arrived at the what we wanted to find out was value of a call option. Okay, we have not found out the value of a call option in the whole process. The value of the call option today should be equal to the cost of the replicating portfolio. Okay, so the cost that a call option buyer will incur today should be equal to the cost of the replicating portfolio. Reason being, both of them have the same payoff in future. Okay, this payoff can be either 33 or 0. Okay, when two securities have the same payoff in future, today they must have the same price. Okay, there can be no reason why call option and the replicating portfolio should have separate prices. If they have separate prices, you can actually carry out arbitrage. Okay, and for prevention of arbitrage, call option and the replicating portfolio must have the same price today. Okay, so now let us calculate the cost of replicating portfolio. Cost basically refers to the cash outflow today, right? Cost is basically the cash outflow today. So what we are going to do is the cost, we're going to buy 0.76 shares, or it was 0.7622 shares. Okay, we're buying 0.7622 shares at t equal to 0. And you know that each share is worth 170. Okay, so your cash outflow is 0.7622 into 170. Okay, I'm denoting cash outflow as positive. Okay, I'm denoting cost as positive and cash outflow as positive over here. It's fine. Okay, so 0.7622 into 170 is going to be the cash outflow for buying 0.76 shares. But then the whole amount is not a cash outflow for you. You're going to receive some money, which I'm denoting as negative. You're going to receive 110.16 because you have borrowed 110.16 today. Okay, so 0.7622 into 170 is your cash outflow, and you're going to receive 110.16 as cash inflow because you've borrowed that amount. Okay, and when you solve for this, the answer will be 0.7622 into 170 less 110.16, which equals 19.41. Okay, so the cost of the replicating portfolio at t equal to 0 is 19.41. Okay, and we said that the cost of call option or value of call option at t equal to 0 should be equal to the cost of replicating portfolio, which is equal to 19.41. Which means if you try to replicate the payoff of a call option at future, that replicating portfolio has to have a price of 19.41 today. Which means if you pay 19.41, let's interpret what this 19.41 cost is. If you pay cost of replicating portfolio, right? If you pay 19.41 today, you will receive either 33.07 or 0 in future, depending on what the share price is. Okay, that is the interpretation of cost of replicating portfolio. Now, the payoff from a call option also has a payoff of either 33 or 0, which means the cost of the call option also today has to be the same as the cost of replicating portfolio, which is 19.41. Okay, I have intentionally denoted cash outflow over here as positive and borrowings as negative, because cash outflow is generally denoted as negative and cash inflow is denoted as positive, right? But the reason I did is when somebody asks you the cost of Apple, you don't say cost of Apple is minus 60. You say cost of Apple is 60 because it's understood that cost refers to a cash outflow, right? You denote it positive. Okay, the similar way I denoted cash outflow as positive and cash inflow as negative at t equal to 0. At t equal to 6 also, I denoted cash inflow. I mean, I basically reverse the signages at t equal to 6, wherein I denoted cash inflow as positive and cash outflow as negative. Okay, so I've basically used opposite signages at t equal to 0 and t equal to 6. Don't get confused with that. Okay, so the cost of the call option is 19.41, and we knew that the cost of option should be 19.41 because we already calculated it using the risk neutral method where the cost is 19.41. Okay, so so as per the single period binomial model replicating portfolio, the cost of a call option is 19.41. And if I actually split this 19.41, if you look at this 0.7622 shares, okay, the cost of replicating portfolio 19.41 can be split into two, right? It is 0.7622 of fund. Okay, let me just 19.41 can be split into two. One is buying delta shares. Remember, I'm denoting cost as positive. Okay, cost being denoted as positive 19.41. I'm buying delta shares, which is 0.7622 into 170, which is 129.57. Okay, so the cost of buying delta shares is 129.57, and I am borrowing where I'm receiving a cash inflow of 110.16. Okay, so the cost can be broken down into two components: buying delta shares and borrowing some Y amount of money, where Y is 110.16. Okay. Okay, this is how the cost of call option can be broken down. Now I'm writing the equation of Black-Scholes. Call option value is equal to S into ND1 minus present value of exercise price into ND2. And we know that ND1 is actually nothing but delta. Okay, ND1 is delta, which means this is cost of buying delta shares, which we actually put it as part of this branch, less this is the amount of borrowing. What we got as Y over here is nothing but this. It is the amount of borrowing. Okay, so what we are actually doing under Black-Scholes is exactly the same as what we were doing under replicating portfolio in a single period binomial, where we said replicating the cost of a call option can be broken down into two: the cost of buying delta shares and offset by some borrowing. Okay, because a call option can be replicated by buying delta shares financed by some borrowing. It is leveraged stock buying, right? So you buy certain shares and you finance it with borrowing. The same thing the Black-Scholes is saying. S into ND1 refers to buying delta shares less present value of exercise price into ND2 is nothing but borrowing. Okay, and what the interpretation of present value of exercise price into ND2 is, let's say there is a zero coupon bond whose face value is equal to E. The face value is equal to E of 160. Okay, the price of the zero coupon bond today will be, let me not write P0. The price of the zero coupon bond today is going to be equal to present value of E. Okay, so present value of E is the present value of a zero coupon bond whose maturity is T equal to 6. Maturity T equal to 6. Okay, the face value is 160, or the exercise price. So the price of a zero coupon bond is equal to the present value of exercise price. Okay, and what it is saying is you buy delta shares by shorting. Okay, you're short selling. Remember, when you're investing in a zero coupon bond, you're lending money. When you short sell a zero coupon bond, you're borrowing money. Okay, because when you short sell, you basically receive money, right? Okay, so short selling a zero coupon bond is equivalent to borrowing. Okay, so basically this latter term says you short sell, or I'm just writing short, ND2 units of zero coupon bond whose face value equal to exercise price and term is equal to 6 months. Okay, so a call option can be understood as leveraged stock buying. We know this. Okay, and the equation of Black-Scholes is exactly saying that. It is saying that the cost of a call option is equal to cost of buying delta shares, which is financed by, or which is supported by financed is the right word, which is financed by shorting ND2 units of a zero coupon bond whose face value is exercise price. If the face value is exercise price, the price of, if the face value is exercise price or the strike price of 160, the current value of the bond or the today's price of the bond is going to be present value of the exercise price, right? Because today's value of a zero coupon bond is the present value of the future cash flow. Future cash flow is nothing but the exercise price, okay? So we are going to short. Shorting means borrowing ND2 units. In our, if you remember, when we solved for the Black-Scholes equation of a call option, ND2 that we got was 0.7540. Okay, ND2 was actually 0.7540. So what Black-Scholes model okay, let me just write. When we solved the Black-Scholes answer with the same set of numbers of 170, etc., we got ND1 of 0.7923. And we got ND2 as 0.7540. Okay, these were the values that we got when we solved the same set of facts. We had these facts, right? When we solved the same set of facts under the Black-Scholes, these were the values that we got. Okay, so the Black-Scholes is saying that the value of a call option today is equal to buying 0.7923 shares, which is financed by shorting 0.7540 units of zero coupon bond whose face value is equal to exercise price and term is equal to 6 months. Okay, so the Black-Scholes is exactly doing what the single period replicating portfolio for a call option did. Okay, the only thing if you observe is what we got as H over here is 0.7622. That was the delta, what I called as delta, and ND1 is also the delta, that is 0.7923. Over there in a single period it was 0.76, whereas in Black-Scholes ND1 is delta of 0.79. Okay, the reason is because now we have moved from a single period to multi-period and the delta has actually improved. Okay, the calculation of delta has actually improved from 0.76 to 0.79. Okay, obviously if you break the whole term of the option contract into infinite small steps, your working or the calculation improves, right? Okay, so we saw that ND1, the delta as per single period was 0.76, whereas the delta as per Black-Scholes model is 0.79. Okay, so as per the Black-Scholes model, a call option can be replicated by buying 0.7923 shares and shorting or borrowing 0.754 units of a zero coupon bond whose face value is exercise price and term to maturity is 6 months. Okay, so the cost of the call option today is nothing but the cost that you will incur for buying 0.7923 shares, which is a cash outflow denoted as positive, but you're going to offset that cash outflow by a cash inflow which we are deducting from our previous cash outflow, and we are going to receive that money by borrowing, by short selling 0.754 units of zero coupon bond. Okay, so when you short sell a zero coupon bond or a treasury bond, it means that you're borrowing money at risk-free rate. When you're investing in a zero coupon bond, you're lending money to the government at risk-free rate. When you're short selling a zero coupon bond or a treasury bond, you're borrowing at a risk-free rate. Okay, so a call option can be replicated by buying 0.7923 shares and short selling 0.754 units of zero coupon bond. So if I quickly do a comparison between the answers that I got as per binomial model and the answers that I got as per the Black-Scholes, say this is binomial and this is Black-Scholes. Okay, the value of call option that we got under binomial was 19.41, and the value of the call option when you use the same set of figures in the previous session, the value of the call that we got was 18.20. So we used the same set of figures of 170, 160, etc. And when we calculated ND1 and ND2, we got a value of 18.20. Right? So the value of a call option has basically improved, or the methodology to calculate the value of a call option in single period binomial. We were just assuming that the share value will change only once at maturity, and the share price can only take one of the two possible values. Okay, when we are now breaking that assumption, we have broken those assumptions, restrictive assumptions, and we are now revising our valuation of a call option under the Black-Scholes model, where we say that the share price can change every moment, and a share price can take any possible range of values at maturity. Given those circumstances, the value of a call option is 18.20. Okay, so under Black-Scholes model, we have basically improved our methodology to calculate the value of call option. Under binomial, the delta that we had was equal to h. What we denoted as h was itself delta, and I think it was 0.76 something, right? What did we get above? We got 0.7622 shares. That was the value of h. H is equal to 0.7622, or delta is equal to 0.7622, whereas delta under Black-Scholes model is equal to ND1. ND1 is nothing but delta, right? So delta is equal to ND1 is equal to, I think it was 0.7923. Okay, so basically the delta also has improved, meaning the methodology to calculate delta has also improved. Under binomial, we were saying that the delta of a call option is 0.7622, and under Black-Scholes, our methodology of calculating delta has also improved, and we are now saying that the delta is 0.7923. I am not at all emphasizing on the fact that delta has increased or decreased. Okay, I understand that going by the numbers, delta has increased. Okay, but I'm not really commenting on that. What I'm just trying to say is our methodology to calculate delta has improved, resulting in a change in number. Of course, it's a slight change. It's just changed by 0.03. Okay, so the value of a call option has basically decreased from binomial to Black-Scholes by about 1.2, and the value of delta from binomial to Black-Scholes has increased. Okay, but my emphasis is not on increase and decrease. It's basically, I'm just trying to say that the calculation of methodology under Black-Scholes is better than the calculation methodology under binomial, because binomial had some restrictive assumptions. Okay, but binomial also gave a value which is not completely far away. It is given a value which is almost close to what Black-Scholes is giving, but there is a marginal difference. Okay, the delta is 0.7622 and 0.7923. Therefore, under binomial, the value of a call option, the way we viewed it is 19.41. We broke it down into two parts. One, buying delta shares, whereby each share today was 170, right? So delta over here was 0.7622 into 170. This is basically the calculation that we did above. 0.7622 into 170 is 129.57, equal to 129.57. And the second component is borrowing Y, where Y is equal to 110 point something, 110.16. Okay, so the value of a call option under binomial model 19.41 can be seen as buying delta shares and borrowing Y, whereas the value of call option under Black-Scholes model of 18.20 can be seen as having two components, the same two components, buying delta shares, which is nothing but the first component. S into ND1 is nothing but buying delta shares. Okay, so the first component of Black-Scholes model is buying delta shares, which we actually, we can calculate over here. Okay, let me just, it is 0.7923 into 170. We actually calculated the same value in the previous one. So 170 into 0.7923, I've written it as 134.69. Okay, 134.69, and the difference between 129 and 134 is obviously because of change in delta, right? That is the only change, because the current share price is same under both binomial and Black-Scholes. Obviously, the current share price is current share price under any model, right? Okay, what has basically changed is delta, and that is why under Black-Scholes you're viewing buying delta shares as a cash outflow of 134.69, and that is being financed by ND2 units of zero coupon bonds being short sold or being sold. Okay, I'm just writing in brackets as selling. Okay, we are selling ND2 units of zero coupon bonds, which is nothing but borrowing. Okay, and ND2 was basically, in our example, ND2 was 0.7540. So 0.7540 into present value of exercise price, where exercise price was 160. So we did 160 divided by 1.0356. Okay, 160 divided by 1.0356 is nothing but the price of one zero coupon bond. Okay, because the face value is 160, the price today is going to be present value of 160, which is 160 divided by 1.0356 into 160 divided by 1.0356. Okay, and when we further solve for this, we have a value of, sorry, I'm just taking values from the previous calculation to save some time, 116.49. Okay, so under binomial, we assume that the value of our borrowing is 110.16, whereas under Black-Scholes, we are saying that the value of our borrowing, the value of the short sold number of units is 116. Okay, so this has gone up basically by 6 rupees, and this delta shares, the value of delta shares purchased has gone up by about 5 rupees, and there is a net reduction of 1 rupee, which you are able to see in the value of a call option. Okay, so binomial and Black-Scholes, and this ND2 units of ZCB is nothing but the second term, right? I mean, this second term, present value of exercise price into ND2, is what the second term is, which we are saying as borrowing Y. Okay, so Black-Scholes and binomial are doing one and the same thing, just that the value of delta has improved and also the value of borrowing has now changed. Okay.